All right. Hello, everyone. Are we live? Can people hear us? Great. So, welcome back. Welcome back to another exciting workshop. So far, we have learned a lot about machine learning, right? Today, we had a workshop about TensorFlow and how you can create your models in TensorFlow in 6 easy steps. But now, since you have learned how to build your models, let's learn about how you can integrate your machine learning models to your applications. And for that, we have Yunfei Luo, who's a PhD student at University of California, San Diego, with us. He works in applied machine learning in signal processing and healthcare, and we'll get to know some very exciting things with him. We'll be focusing on practical use of Hugging Face API and GPT API to seamlessly incorporate powerful machine learning models into applications that you're developing. So I really hope you will gain a lot from this workshop, and it's over to you, Yufai. Thank you so much.
Okay, thanks. Okay, okay, so let's maybe start with a bit more introduction to the overview of how the machine learning looks like. So nowadays, there's a lot of data source out there, like a lot of modalities. We have like vision from cameras, we have text-based documents, and we also have this signal data from a lot of sensing device like phones, Apple Watch, things like that. And then there's a lot of experts and researchers works in the field and doing like feature extraction and like image processing, natural language processing, and signal processing to kind of extract informative but complex features from those data. And those features and techniques can be further used to do the actual application, like categorical classification or object segmentation, or like regression usually used in like next value prediction or like stock prediction, and also generator. So usually this could be either image generation or text generation, like what ChatGPT does, and also like decision making. And so usually the traditional pipeline for machine learning, I think also already introduced in previous workshop. So first of all, we have like data collection, and then we have to construct a model to design how the model looks like, and then we train the model based on the data we have, and we have to validate to see how the model perform on a validation set, and then we tune the hyperparameters such as the number of layers, the like the size of hidden layer, and also learning rates, weight decay, and a lot of hyperparameter. We're just tuning and retrain the model and then revalidate. So there's a loop within here until the model gets a well-performed performance. And then finally, after validation, we'll have to actually test the model, like actually deploy the model or in a test scenario. And usually there will be feedback from the actual deployment scenario, and we have to kind of improve the model based on the feedback from the test scenario. Like say if the customer not happy with the model, then we probably have to do a troubleshooting, see whether it's a problem with the data or it's a problem with the model, and then we have to improve the model and redo this training hyperparameter tuning thing. So basically, there's a two loop here. One inner loop is this train and validation to kind of actually train the model, and a outer loop, which is tuning the model and test the model, then retune the model, retest the model. So this pipeline is actually is most of the scientists and engineer in industries does. But it is not very efficient in case, for example, especially in hackathon, we only have 1 or 2 days. So we couldn't do all of those stuff like search for data sets, train the model, and stuff like that. Or even we have like computation resource limitation. So what we'll do is that suppose we already has those large communities of developers, industries, domain experts that will do those stuff like modeling, testing, remodeling, retesting, and then the model will be provided to like API providers such as Hugging Face and OpenAI, which is the main focus of the demo that I will show later. And then we're gonna do is we directly use the API from this provider and to integrate this API into our. So we just prepare the inputs of our data and we use their API. Then we directly use the output from the model for further task in our application, either mobile application or the like PC application. And now let's first start with the Hugging Face API. So just for preparation to make sure you just sign up an account, and usually in the setting, there's an access token. So this token is just used for calling the API. And you can just copy paste the API into your code, and then we can start to kind of I will start showing the model. I mean the demo. So first of all, you have to like set up the token, like just set the API token and have this like header in this format. So I think this demo, the link will share later, so you can have direct access to all of this code. And okay, so for when calling the actual API, so the calling usually consists of two things. One is the prompt and one is the API URL. So the prompt can be either be text or images. So this is the inputs of like your inputs that you want. Like for example, if you are doing image classification, then this prompt will be an image, and API URL is the actual model, like the URL provided by Hugging Face. And so for example, let's first jump into a demo that will be more intuitive to solve. So for example, if we are doing like text to image application, like we input some text and it output the image. So there is a model on like Hugging Face that we can see is a stable diffusion. And so Hugging Face is a very large community. Like you can like search on this website. They have a lot of models, and you can either like check feature extraction, text to image, or stuff like that. And they has lot of model on the list. And so usually in this case, for example, I'm using the like you can sort by most likes or most download. You can, so in this case, I'm using the stable diffusion one. And so this is how exactly the URL is being used. So I just pass the images, like I'm just pass the prompt and the API URL to this API. And for example, in this case, let's actually go. So for example, if I'm doing say laptop, smartwatch, wearable sensors, and see how things might go in. Just need some seconds. Okay, yeah, actually, I have to wait. I'm not sure how long will this takes, um, but what it's supposed to return is a image bytes object. Okay, so for example, this is the image like generated from the from this stable diffusion model, and we can also give some other prompts. So say for example, I don't know, like Harry Potter and cartoon style, and it will probably give a new image based on this prompt. So so you can play with this API and like try out several prompts and see what's the output. And you can, so this will actually return a image object. So usually it's RGB in a matrix format, and you can directly use this output in the application for like any other passing into any other function to do other tasks. And so this is the first demo that we can actually do this image generation stuff. Oh, okay. Well, and then we can do like for example a text like a natural language model. So for example, in this case, I'm using a text sentiment analysis. So this is also a model that so there's a lot of sentiment analysis model on Hugging Face. So you can check out the description of the model. That will usually describe like what's the architecture of the model, what's data they're training on, what's the performance, and also if they have a paper, then they will put the link of the paper on it. And they will also have those codes for showing like how to actually use the model locally. But here we're gonna still use only the API, like in this case, we just directly pass the URL of the API. And so this URL you can usually get like on Hugging Face, there's a deploy, and you just click inference API. So they will provide the API link in this demo code. And so in this case, So for example, if we're doing like, if the statement does not make sense, so this is just oh, just give me a second. What's wrong? Okay, so for example, in this case, the prompt is still a text. So for example, if I pass in the statement does not make sense, and the output will result in, so either say this sentence has a negative or neutral or positive with is their corresponding score. So this is actually the output of the model, and you can directly use this. So it will output this JSON file, and you can directly use it for further application. And we can also try, say, hackathon is interesting, and it will probably has like a higher score being assigned to like positive, saying this sentence is more positive. And also we can do like text to music. And so this is also a music generation model that's you can easily find on the website. So basically it's still like you pass in a like a text, and it will give you a back an audio file. So for example, in this case, if I'm doing, say, like pop song, like some rap and R&B, and then it will result in, oh, just there's some like file confliction error. So what it does is that I just declare this function, so it will pass the query to like this query, for example, the pop song, some rap, and to the API URL, and it will save the file like locally. So in this case, it's on Colab. So if you are doing it locally, there will not be those like file confliction error. So what I'm done is I just like save it on the Colab and play the music. But yeah, seems like there's some error. Oh, okay, I hear the actually it's generated by this generation model with just with this text-based prompt. And so this collab will be shared with you, and so you can play with, you can directly copy the codes and copy the functions and play with different prompts and see whether the output could be used in the in your application. Or if you're having some, so there's a lot of models out there in the Hugging Face. So they also have like text classification or summarization or object detection, and so they have a lot of models there you can directly use. So all of them basically have the same calling format. So they will provide your URL. So what you need to do is you prepare your inputs, either be text or image or music, any modality, and then you just pass that to the API and your API URL and guess the results, read the results. Okay, and let's. And another demo I want to show is the about the ChatGPT. So this one, so usually in the website, the website version of the GPT, they already have a like a built-in prompt. So for that prompt, we couldn't change, and it's hidden from the users. So so when we actually use the API of the ChatGPT, the performance is usually much better than the web page version, and you can directly you can customize your prompts in with careful prompt engineering to have a better output. So for example, in this case, let me see. Oh, just give me a second. I had to go back to the slides. So just make sure. So for the OpenAI API, you have to sign up accounts, and you have to link your credit card to the. So usually you will have a free trial on when you first sign up, but after the free trial, you have to you have to link a credit card to the OpenAI, so you will be able to use chat like GPT 3.5 or GPT-4. So in this case, just assume we have everything set up, and in the collab we have to first install OpenAI. And the way to use the API is we first define the key and we define the version of the model. So in this case, I just use GPT 3.5. And when we actually call in the model, so there are several parameters we have to set. So one is the temperature. And so the temperature is like how variant this thing could, like the output could be. So for example, if I set temperature as like 1, like in this case, I just use default value of 0.6. If I use 1, then the output could be very random. And so there will be more variance. So if you keep asking the same thing, the response will be very different each time. But if I set temperature to 0, then if I keep asking the same question, the output will always be the same or with very less variation. So this parameter is called temperature, and then you pass in the message. So the message is the main contents of your prompt. So in this case, the contents could be the question you ask to it, or could be the like a text that after the prompt engineering. So I will talk about prompt engineering later, but in this case, I'm just talking about like how you call the API. And the role is that they have like 3 roles. They have like assistant. They also have like users and system. So the user prompt is like same thing when we use the ChatGPT on the web page. So it's more like if you want to ask questions, then you probably want to put the contents under like user role. And if you are doing like a like text completion, say like you have a beginning of a story and you want to complete the entire story, then it's usually using the assistant. And for the system, it's usually a instructional prompt. So say, for example, you want to define what's the role of the GPT you want it to be. Like you want it to be a teacher, you want it to be a writer or speaker, like anything. So all those settings have to be put under the role of system. So in this case, I'm just using assistant. So actually, in the actual case, the performance doesn't differ that much. So just by default, I'm using assistant in this case. And so and this function will actually just parse out the result from ChatGPT and return a final response. So for example, in this case, I can like, for example, show how to use ChatGPT to do like for example, summarization. And in this case, I'm doing a prompt engineering. So the format I use is a Markdown format. It will consist of like titles and with sentences under each title, and then like setting the task. So for example, in this case, this is the background. I just pass in this like the summarization of the this hackathon, like what it is, and then I assign a task, say like you're a professional teacher and please analyze and polish the above sentence. And then I'm asking it to output this format. So the formats I'm using these things called like chain of thought. So usually if you directly ask like GPT to answer questions, usually the performance is not very well because of the hallucination problem. So what we could do is we just ask the GPT to do things like step by step, like don't directly jump to the answer, but do some analysis or like more easier step before. So for example, in this case, I just want to rewrite this intro sentences. So I will first ask the ChatGPT to do like a summarization of like what original intro looks like, and then a thoughts like how you thought here, how well to analyze how well this is written and which aspect could be improved. And then say, for example, I will ask it to give a score and then the final response. Because so why this like chain of thoughts works, because like the model is output in a sequence, so it will not see what's the output in the future, but what it can see is what's was already have in before. So with the summarize and thoughts and scores, so doing this like analysis step by step, it will have a more concrete conclusion of how the final response should be. So this is why we use this chain of thoughts. And finally, this is a appreciation statement. So this is from a previous studies showing that if you say like good words or appreciation to this large language model, the performance is usually better, and which is understandable because I think there should be a lot of such sentences in the actual training data. So we just include this appreciation sentences in the end. And let's say, so for example, if we pass all of this to the GPT and see what's the output, it might take a while. Okay. Usually, previously, this should give the results pretty quick, but I don't know why today the result is really slow. Probably. So it's supposed to give the result pretty quick, but I don't know why today. Maybe some problem with the ChatGPT or. Yeah, but cases should be like it will output like sequence of text, including the summarization, thoughts, and scores as defined here. But I don't know what's the problem with the API. Maybe the API is down or uh, refresh and see how things go. Oh, okay. I think probably it's the problem with the Colab because the installation is also not work. Yeah, but also the link of this collab will be shared to you, so you can probably test out and see and under a better internet scenario and see how the output's gonna be. Oh, I think I should stop this. Oh, okay. So now we can see the actual results. So it will have the summarization saying the original intro introduced this hackathon as blah blah blah, and it highlights blah blah blah, and then a starts like saying this intro is clear and concise, and well, it in fact it convey information, and then it will say, however, there could be some aspects to be improved, and it gave a final score like 85 out of 100, and then the final response is the new response, like a new introduction probably will be better one based on this analysis. The experience, like first major in the joyous for the 24 hours, but yeah, probably longer one. And so this is just the idea, but you can try this out for like several things, not only summarization, but you can also ask it for like output, like a JSON objects or output like for example essay or any Python codes, things like that, and you can directly use the output for further analysis. Or you can also build this with like easily to make it as a chatbot. Like you can just set a character and set a scenario, and you can just repeatedly like chat with GPT. Like you just send the inputs and ChatGPT give you an output, and you just pass the new in and output pair to the prompt and then recalling the API, and it will become a chatbot. And another interesting thing is the plagiarism check. So this is like this is already being applied in a lot of universities, in a lot of courses. So they use a large language model to do those plagiarism check. For example, especially for exam, especially for take-home exam, like they will usually use this to check whether two students have collaborated or didn't collaborate. And if there's a higher risk, then these two students will usually be asked to go to the professor office to explain whether they actually collaborate or not. And so in this case, for example, I just passed in the original SacHacks introduction, and I just paste a new one from this one. So it's supposed to have a very high plagiarism because they're actually talking about exactly the same thing, but just one with one better version. So in this case, it will give like score of 0.8 out of 1 for like likelihood of plagiarism because they're actually talking the same thing and have very similar content. So actually, you can assign various role to the ChatGPT. Like you can input any prompt here to make it like a customize the role of the GPT. And yeah, and then probably that's all the demo I have. And feel free to ask any questions or confusions. And those code will be shared later on, so you can directly use them and test them out. Oh, no, I couldn't hear. Oh, hi.
Wait, you can now?
Yeah, I can hear it right now.
All right, all right.
All right, so yeah, I already like pretty much done with the presentation.
Okay,
So
sounds good.
yeah.
Does anyone have any questions? We have a couple of minutes too. I think Yunfei on the top, we had a few questions about can we compress the audio files?
What do you mean by compress the audio files?
Rohan, if you're
Uh,
still here, can you clarify your question? Also, somebody asked, does it cost money to use OpenAI API for personal use?
yes, for OpenAI, yes. So so they have a price being listed on the website saying like if you use different model, what will be the price? Usually they have a unit for like 1,000 tokens, but for like GPT 3.5 or like the ChatGPT, it is pretty cheap. It is like 0.0004 for like 1,000 token. So pretty much if I use that to run like even I run experiments on a large collection of data sets, like one trial will cost like $0.5, something like that.
Mhm.
But GPT-4 is pretty expensive. It's like 10 more times expensive than ChatGPT. So,
Got it. Got it.
yeah,
Thanks for answering that.
for Hugging Face it's usually free for Hugging Face. There's a lot of free models there.
Got it. Thanks for
Mhm.
that. The next question is about API security.
Mhm.
JustKit is kind of new to this, and they were wondering how do we make sure that our API keys are secure?
So usually, in this case, so in my demo, like I just directly put the API key in the, oh, wait, just give me a second. I directly, copy the API key in the text, but this is not good practice. Usually in actual development, you have to put the key in like say .env file, like it will be a hit file, and you just in the Python code you directly read from that file. And when you push the code to the like say GitHub or any like remote repository, you, for example, in the git ignore, you just say you ignore uploading the .env file. So your API key will not be uploaded to those public repository, and it's only accessible by yourself. So
Got it. Thanks for answering that. So yeah, Rohan followed back on the question that he asked. The question was, can you compress the audio files? And basically what he's trying to ask is that does it have additional features of compressing the file while it generates it in the code that you mentioned earlier?
I think there's no additional features need to compress. So the API I use will directly give back a time series with like sampling rates, and you can directly save it with like write to bits and write to file, or yeah, you can directly save it. So there's no additional step needed.
Got it. Does anyone else have any questions? This is the right time to ask them if you have any.
Also regarding the security, so for example, if you're using like ChatGPT API, if you are concerned of whether your data will be used or not, so I think especially for OpenAI, they have those disclosure statements saying they will not use your so they have those list of documents saying they will not use your data for any training or saving purpose, or they will not store your data, things like that. So it should guarantee the security. Yeah.
That's fair. Any other questions? I think Manaswini has a question. They're asking any projects that you worked on that use Hugging Face API.
So currently we just use the Hugging Face API for like prototype and demo. So for example, previously we were using like on a mobile app, like for example, we are doing like text classification or text sentiment analysis, and we have our own model, but just for like when showing the demo, like we just use the API because it's more quicker, and also the pipeline is more well-rounded compared with our own pipeline. So we just directly use the Hugging Face API. And in a more like research scenario, we just directly use our model because it usually gives better performance. And
Got it. Sounds good. There's another question. Does the .env variable work for local cases only?
yes. So .env usually. So for example, if you are deploying your application on say AWS or Azure, you can also like put .env on server. That will still works. And yeah.
Sounds good. Any other questions that we have from the audience? All right. I think that should be it. Thank you so very much, Yunfei, for being here. Thank you so very much to everyone who's watching us over here. I hope this was interactive and very informative for you. And once again, happy hacking. We'll see you later.
Yeah. See you.